Hello everyone, welcome to Chemistry. Today we'll be practicing few other previous year questions from the chapter General Organic Chemistry. So let's start the video. So we'll do today a few questions from isomerism topic. So the first question, it will be on your screen. It is 1-butene and cyclobutane shows there are 4 options, that are position isomerism, ring chain isomerism, functional isomerism and metamerism. So before digging to this question, let us understand what is isomerism and what are the different isomerism that we see in any chemical compound. So isomerism is a phenomena in which 2 or more compounds have a similar molecular formula but have different properties. Now this isomerism can be differentiated into 2 broad categories. The first one is the geometrical isomerism and the second one is the stereoisomerism. Now geometrical isomerism can be further divided into 4 parts. The first one is position isomer. I am writing isomer as I, and then functional group isomer, the third one is chain isomerism, and the fourth one is metamerism. So we will study each of this isomerism first. The first one is the position isomerism. Now position isomerism is actually a phenomena in which 2 or more chemical compounds have a different position of the substituent or the functional group. The second one is the functional group isomerism. So functional group isomerism exists in those 2 or more type of chemical compounds in which the molecular formula is same but the functional group is different. The third one is the chain isomerism. So the chain isomerism is also the same. In this the molecular formula is same but the chain length differs in each and every molecules. And the last one is the metamerism. So metamerism exists in 2 or more compounds which has the similar chemical formula or similar molecular formula, but there exist different alkyl chain length in either side of the functional group. Now our question is, what is the isomerism that exists between 1-butene and cyclobutane? Let me write the structure of both of this chemical compound. It's 1-butene. So butene means 4 carbon. So let me write 4 carbon first. And 1-butene means with 1 carbon there will be, between 1 and 2 carbon there will be a double bond. Let me satisfy the tetravalency of carbon with hydrogen. Yes. So this is 1-butene. This is 1-butene structure, and cyclobutane structure is this one. Okay, so in this question they are asking that what is the isomerism that exists between both of this structure. Now we can see that there are 4 options. Clearly it is not position isomerism, and then functional isomerism is not here as well, and the 4th option, that is metamerism, is also cancelled out. Only the one option that is left is ring chain isomerism. Now we can see that in both of this structure, one is straight chain compound and another one is a ring compound. So both of these structures are ring chain isomer to one another. So option B is the right option. So let's start the second question now. The second question is again on your screen. So they are asking, they have given 3 structures. Let me write the structures for you. It is CH3, CH2, 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 1, 2, 3, and then CH3. They have given first this structure and then CH3, CH, CH3, CH2, CH3, and the third structure I am drawing here. So the third structure is CH3, C, CH3, CH3 and CH3. And they are asking that what is the isomerism that exists here. So now, as we have already read that what are the different kind of isomers that exists, now we can easily understand that all of these structures or all of this compound have the similar molecular formula. Let me count it for you. This one has 1, 2, 3, 4, 5 carbon. This one also has 1, 2, 3, 4, 5 carbon, and the last one as well has 1, 2, 3, 4, 5 carbon. So the molecular formula of carbon is same, that all of this molecule has 5 carbon. Let me count the hydrogen for you. So there is 3, 6, 9 and 12. 12 hydrogen in the first structure. In the second one there is 3, 2, 5, 7, 9 and 3. 12 hydrogens, and in this as well 3, 3, 6, 7, 8, 9 and 10, 11, 12. There is 12 hydrogen. So we can see that all of this three chemical compound has a molecular formula of C6H12. We have given 4 options. The options are position isomerism, metamerism, ring chain isomerism and chain isomerism. Let me cancel out what are not the actual options or actual answers. The first one is the position isomerism. Now what is position isomerism? So in position isomerism there will be different position of the functional group or substituent. So there is not different position of different functional group can be seen here. So positional isomerism is definitely not the answer. The second one is metamerism. Again, this one is not the right answer. The third one is the ring chain isomerism. Again, there is no ring and chain involved. There is only chain compounds here. So ring chain isomerism is definitely not the right answer. And option D is the chain isomerism. Now let me recall what is chain isomerism. Chain isomerism is the isomerism that exists between 2 or more compounds in which the molecular formula is same, but the carbon skeleton is different. So we can see definitely this is the chain isomerism. So option D is the right answer. Now the third question. So the third question is that C2H5NO2 and again C2H5ONO. So both of these are example of which type of isomer. So let me draw the structures for you once again. So it says C2H5 bonded with nitrogen, double bonded with oxygen, and there is one coordinate bond with another oxygen. Now the second structure is C2H5 which is bonded with oxygen, which is bonded with nitrogen and double bonded with oxygen. Now please tell me what is the right answer. You already know, so then write the answer in the comment section below. So this one, in this case again the molecular structure is the molecular formula is same, but the functional group is different because the functional group connectivity is different. The NO2 is same in both the cases, but in the first case the CH2 is directly bonded with nitrogen of NO2, and the second case the C2H5 is directly bonded with the oxygen of NO2 molecule. So what will be the right answer? There are 4 options: functional isomers, tautomers, position isomers and metamers. So the option A, that is functional isomer, is the right answer. So the next section we'll go into is the fundamental concept of general organic chemistry or organic reaction mechanism. So the first question we'll try in this section is heterolysis of a carbon-chlorine bond produce. So let me write the carbon-chlorine bond for you. So carbon and chlorine. So in this case, carbon and chlorine, when there is a bond between them, we already know that chlorine is much more electronegative than carbon. So definitely it will generate a polar bond because this electron that is involved in this bonding will be much more pulled by this chlorine. So then in this case, when heterolytic cleavage or simple cleavage will be done, so there will be a cleavage, but instead of a free radical, this chlorine, because of high electronegativity, will take up both of this electron that is involved in this bond formation, and it will come out as a chlorine negative or chlorine minus, and this carbon will come out as C plus. So we can understand that in any heterolytic cleavage, in any heterolytic cleavage, one cation will be released, which is this one, and one anion will be released, which is this one. So I guess the option C is the right answer. So the next question is, which of the following is an electrophilic reagent? So what is electrophile? Electrophile is actually the species which has a tendency to take up the electron towards itself. That means that electrophile is always electron deficient. That's why it has a philia or love towards the electron. So any electrophile, in general, electrophile is denoted as E+. Now coming to the four options that they have given in this question, that is H2O. We know that nucleophile can be of two types. Another one is a neutral and another one is negative charge containing. So in case of neutral nucleophile, it contains a lone pair. So let me see what are the options. The first one is H2O. So oxygen has two lone pairs on itself. So that's why H2O is a nucleophile. The second one is NH3. So in NH3, the nitrogen has one lone pair on itself. So that's why NH3 is a nucleophile. The third option is OH negative. Now OH negative, we can clearly see that it contains one negative charge on itself, so it is definitely a nucleophile. And the fourth one is NO2 plus. So NO2 plus is a definite electrophile. So option D is the right answer. Coming to the next question, it says, which of the following intermediate contain 3 pair of electrons in its valence shell? And there are 4 options: carbocation, option B contain carboanions, option C contain free radicals, and option D contains both A and B, means both carbocation and carboanion. So we all know that carbocations are the carbon species or carbon containing species that has a positive charge on itself. Now let me see that what is a carbocation first. So this carbon, which is bonded with 3 other substituents, that could be a hydrogen or any other alkyl group, when it has a positive charge on itself, this is known as carbocation. Now one of the general feature of carbocation is it can be of 3 types, that is 1 degree, 2 degree and 3 degree. Let me write it for you: 1 degree, 2 degree and 3 degree. And another general feature is carbocation is sp2 hybridized. So both of these features are not related with this question, but so after that, question is, which of the intermediate contain 3 pair of electrons in the valence shell? So definitely the answer is carbocation, because this has 1, 2, 3, 4 and 5, 6. We all know that carbocation has a sextet type of configuration. So that's why in this question the right answer is option A, that is carbocations. So coming to the next question, it says hyperconjugation is not possible in which of the following options? There are 4 options. So let me introduce what is hyperconjugation to you. Now hyperconjugation is a stabilizing factor which operates only in those compounds in which there is the presence of alpha hydrogen. Now we have to see that in these 4 options that they have given in this question, whether in these 4 options there is any compound in which there is no alpha hydrogen, and if we found any compound that has no alpha hydrogen, that means there will be no hyperconjugation, and that's how this hyperconjugation will not be possible in that compound. So let me write all these 4 structures for you. The first one is CH3, CH, double bond, CH2. The second one is CH2 double bonded with CH2. The third one is CH3, CH3, CH3 plus. And the fourth one is CH3, C double bond C, CH3, CH3 and CH3. Now alpha hydrogen means what? Alpha hydrogen means that in any hyperconjugable system, like in any system, if there is an unsaturation or any vacant p orbital, if there is an unsaturation means double bond or triple bond, and vacant p orbital means there is a positive charge like carbocations. So carbon that is attached with that particular carbon is known as the alpha carbon, and the hydrogen that is attached with alpha carbon is known as alpha hydrogen. So in my first option, this both carbon are double bonded with each other. Now this is unsaturation, because double bond and triple bond are known as unsaturation. So the carbon that is directly attached with the carbon which is actually unsaturated, so this carbon is the alpha carbon, and the hydrogen that is attached with the alpha carbon is known as alpha hydrogen. So this compound has 3 alpha hydrogen. Coming to the third first. Okay, so in this case, this carbon that is present in between has a vacant p orbital. So carbon that is attached with this carbon are known as alpha carbon. So there are total 3 alpha carbons, and the hydrogen that is attached with 3 alpha carbon are known as alpha hydrogen. So there are 3, 6 and 9, total 9 alpha hydrogen. Coming to the fourth structure. So in this case again there is unsaturation. So unsaturation is here. So both of the carbon that is unsaturated, this carbon and this carbon. So the carbon that are attached with both of this carbon are known as alpha carbon. So these are 1, 2, 3, 4. There are 4 alpha carbon, and there are 3, 6, 9 and 12 alpha hydrogen. So we can see that in all of these 3 structures they have alpha hydrogen. Let me see what compound B has. So in this case there is an unsaturation again, and this carbon and this carbon are directly attached with each other by a double bond. But in this case there is no other carbon attached with both of this carbon which are doubly bonded with each other. So there is no alpha carbon, and if there is no alpha carbon, then there is no alpha hydrogen. So in this case, only and only this case, there will be no hyperconjugation present. So option B is the right answer. So coming to the next question, it says decreasing order of stability of the following alkenes is. So in this case, all of these 4 structure are alkene, and they are asking for the stability order. Now I have already told you that hyperconjugation is a stability factor which runs only and only when there is an alpha hydrogen presence in the compound. So let me draw all of this structure and let us know that which one is the most stable compound. The first one is CH3 CH double bond with CH2. The second one is CH3 C double bonded CH double bonded with CH single bond with CH3. Third one is CH3 CH3 double bond CH CH3. The last one is CH3 carbon double bond CH3 and CH3. Now pause the video and try to answer this question, because we have already discussed the hyperconjugation factor right before this question. Okay, so let me start answering the question. So let us answer the stability order of all of this compound by the hyperconjugation factor. Now in this case, this carbon and this carbon are doubly bonded to one another. So the carbon that is right beside this carbon is 1. So there is 1 alpha carbon and 3 alpha hydrogen. So here there is 3 alpha hydrogen. Coming to the option B. So in this case, this carbon and this carbon are doubly bonded. Then the carbon that is directly attached with both of this carbon are known as the alpha carbon. So in this case there are 2 alpha carbon and there are 3 and 3, total 6 alpha hydrogen. So there is 6 alpha hydrogen. In option C, there is unsaturation, and this carbon are doubly bonded with one another. So in this case, this carbon and this carbon is the alpha carbon, and let me count the alpha hydrogen. So 3, 6, 9. There is 9 alpha hydrogen. One major mistake that everyone does is that they directly count the hydrogen that is attached with the double bonded carbon. Please don't do that. Try to find out which is the alpha carbon first, and then you can find out what is the alpha hydrogen, and that will be very easy. And if in condensed structure you try it hard to find which one is the alpha hydrogen, then please write the complete structure and then find out. That will be easy for you. Okay, so in this case there is 9 alpha hydrogen, and in case of option 4, this carbon and this carbon are directly doubly bonded with one another. So there are 1, 2, 3, 4 alpha hydrogen, and there are 12 alpha hydrogen. Sorry, there are 4 alpha carbon and 12 alpha hydrogen. So 3, 6, 9 and 12. We all know that more the alpha hydrogen is present, more there will be hyperconjugation effect and more will be the stability. So option B is the right answer, in which 4 is more stable, then 3, then 2, then 1. So the next question is, the most stable free radical among the following is. Now what is free radical? So in case of homolytic cleavage, when a bond is cleaved homolytically, so there will be a fish hook arrow in both of the side, and there will be a generation of free radical, just like this. So when this bond will break down homolytically, then there will be one fish hook, another fish hook arrow, and it will create 2 free radicals. Now these free radicals actually have a septate electronic configuration. It has 7 electrons in its valence shell, so that's why it is again electron deficient. Now in this case, the most stable free radical among the following. So there are 4 options. Let me write 4 options. The first one is, there is a benzene group CH2 and CH2 dot. So in all of this 4 structure, there is a free radical, here is another free radical, and here is another free radical. So for the most stable free radical, we have to understand what are the stabilizing factor that acts on all of this structure. So let me go to the first option first. So in this case, as the free radical is present here, so it cannot undergo to the resonance with this benzene molecule. So there will be only one option for stabilizing this molecule, is the hyperconjugation. Now let me see, this carbon when directly attached with this carbon, so this one is the alpha carbon, and there is 2 hydrogen attached directly with the alpha carbon. So in this structure there will be 2 alpha hydrogen. There is no other stabilizing factor that acts on this molecule. Let me come to the second structure. So in this case, the free radical is present in this carbon. So this as this free radical is present on this carbon, so it can undergo a resonance through this benzene molecule, as well as there is 1 alpha carbon present. So there will be 3 alpha hydrogens. So total there is resonance and there is 3 alpha hydrogen. Okay, so coming to the third option, in this case the free radical is present on this carbon, so definitely it will undergo resonance, but in this case there is no alpha carbon, that's why in this case there is no alpha hydrogen. Coming to the fourth option, now in this case the free radical present in this carbon, that's why this free radical can undergo resonance with this benzene, so definitely there is resonance effect. Plus there is 2 alpha carbon, and that's why there is 6 alpha hydrogen. So in this case, the stabilizing factors are resonance and 6 alpha hydrogen. So just answer with your common sense and write it in the comment section below that which one you think is the most stable free radical compound, and I'll answer it maybe in the comment section. So thank you everyone for joining me today. I'll be happy to see if there is any right answer in the comment section. And for more content, please stay tuned, and if there is any problem, please write to me. I have a Instagram channel that is also named as Chemstrategy, and you can directly comment here. I'll read the comment and I'll definitely try to reply everyone. Thank you.